So one of the most important things about the way in which we understand how the physical world operates around us is by understanding what causally influences what. Is this a cause of that illness? Is this a cause of that health benefit? So and so is very, very fit. What are the kinds of things that they do that cause their health and fitness? These are things that we're all interested in, and understanding the relationship between causes and effects is one of the most important aspects of understanding how the world around us can influence us. And critical reasoning is about understanding the relationship between causes and effects and how we can make inferences from causes and effects and from effects to their causes. The person whose work was very concerned with the relationship between causes and effects and what kind of information we can draw from that is a British philosopher whose name is John Stuart Mill, and he lived in the 1800s, and he formulated certain methods for identifying causes. And a lot of these methods are now considered fairly common sense. And even before John Stuart Mill, I'm sure these methods were used. John Stuart Mill is just somebody who came up with a precise formulation of the methods that people probably used for centuries even before him for identifying causes. At any rate, we'll use his terminology, like the method of agreement, the method of difference, etc., the different methods that you'll be introduced to. These are terms that go back to John Stuart Mill, who has come up with different ways of identifying causes. So one of the methods of identifying the relevant cause of a certain effect that we're interested in explaining is called the method of agreement. And it's called the method of agreement because it's all about, as you can see from this chart, how when a certain effect, in this case an illness, that it means effect, how a certain effect can be traced to a certain cause. And in this case, we have three individuals, Alvin, Bianca, and Charlie, who all unfortunately get sick. That's the effect. And we want to figure out what caused that effect, what caused their illness. And on this chart, we have the things that they ate. They presumably had a sandwich of a certain kind, and Alvin had ham, and that's what these little check marks mean. So did Charlie, but Bianca did not. Bianca had cheese on her sandwich, as did Charlie. And Alvin had tomato, as did Charlie. But all three of them, it turns out, had lettuce. And only Bianca had a pickle on her sandwich. At any rate, the only thing that's common to all three of them in the instance in which they get all sick is that they had the lettuce in common. They probably had some kind of contaminated lettuce. So in this case, you could rationally infer that because there's an agreement in the cause, namely the lettuce, that this is what led to the illness in this particular case. And this is the way a lot of scientific studies are conducted when we're trying to isolate a cause for a certain effect. So if there's a certain outbreak of an epidemic going on, and this happened a couple of years ago, certain people got very sick all across the country from food poisoning. And through careful research and a lot of close examination of what people ate all across the country, which is a tremendous amount of data, it turns out that people had consumed spinach that was processed at a certain farm. That's the cause that they all had in common. So even though people from all across the United States, like California and Massachusetts and Texas, all of these people had gotten sick at a certain time in all these different locations. It turns out that one thing that they had in common is that they had consumed spinach that was processed at a certain farm. And on the basis of tracing the commonality, people were able to figure out where that foodborne illness had come from. And what these investigative journalists and scientists were doing is they were using the method of agreement. Now, the method of agreement isn't just only when certain factors are present, which this example illustrates. Agreement can also be due to a common absence. So here is an illustration of exactly how that could work. In this case, we're using the same individuals again, Alvin, Bianca, and Charlie. It turns out none of them have health. So none of them are healthy. So let's just put an X mark next to all of them to indicate that none of them are healthy. Well, why is that? Well, if you look at all the things that they're exposed to, it turns out they are all exposed to different kinds of things, and yet the one thing that they all have in common in terms of what they're exposed to or not exposed to for their lack of health is they're not exposed to clean air. So in this case, it's the absence of clean air that explains the absence of health. So it's the absence of clean air that causes this bad effect of relatively poor health. So the method of agreement is about looking for all the factors that the individuals who are influenced by a common effect, what they all have in common. And it could be something that's present, like a bad lettuce leaf, or it could be something that's absent, like clean air. The point is, we can trace the cause by tracing what is common, or the commonality. The method of difference works differently from the method of agreement. And here, what we're looking for is, here the situation is different. In this case, the very setup of the situation is different in that we have a case where somebody has a certain outcome. So Yolanda is sick, unfortunately, but Xavier happens to be perfectly fine. And the way that we would try to figure out why it is that Yolanda got sick and Xavier didn't, even though they had the same meal, or relatively the same meal, is by looking at what factor differentiated the two meals that they had. So if Yolanda got sick, This is the effect again. And it turns out that they had pretty much the same sandwich, except Yolanda had tomatoes on her sandwich and Xavier did not. In other words, that's what was different about Yolanda's health outcome, which was illness, and Xavier's health outcome, which was he was perfectly fine. The thing that differed in what they ate was the tomato, and in that case, we could identify the tomato as the cause of Yolanda's illness. So, depending on the setup of a situation, sometimes it's going to be the method of difference that you look for, or the method of difference that you use in order to identify what caused what. In the most reliable cases, you're going to actually combine the two methods. And this is what's called the joint method of agreement and difference, joint meaning combined. And in the combined method, you're going to look for commonality to identify the cause, and again, difference to make sure that the cause that you've identified is the relevant cause, and the way in which this diagram is set up basically illustrates how you could use a combined method of difference and agreement. And this is basically the main setup for what's called controlled experiments. Controlled experiments are experiments that scientists use to try to determine in a laboratory context whether a certain thing causes a certain effect. So if you want to figure out whether a certain drug is effective in curing a certain illness, you're going to want to combine the two methods. You want to make sure that all the people who take the drug actually get better. So in this case, the people who actually take the drug takers, are the people who actually get better. And this is going to be the method of agreement that you use. And then to make sure that those who actually got better, as opposed to those who didn't get better, so unfortunately those who weren't cured, people like Bob and Dennis and Fred, were the ones who took a placebo. Placebo being a pretend curing agent. It's usually in the form of a sugar pill where you basically administer something that looks like a drug as far as everyone is concerned, but it actually doesn't have that active ingredient. And placebos are very effective in the method of difference to guarantee that the drug that you're testing for is actually effective. Because if the drug that you're testing for is no more effective than the placebo, it means that the drug really doesn't do anything. So scientists put in a placebo as a way of implementing the method of difference. If you don't see a difference between the placebo, which is really another way of saying that you don't take the drug that you're testing for effectiveness, in order to make sure that the drug is actually effective, you should see a difference between those who take the drug and those who don't. If you don't see a difference between those who take the drug and those who don't, that means that the drug is not effective. So that's how you use the method of difference. in the controlled experiments. And of course, the method of agreement is about making sure that everyone who does take the drug actually does get cured or does improve in some way. There's also what's called the method of concomitant variation, and that is a very fancy word for, concomitant is a fancy word for happening at the same time. So, this is another very common sense method that we use in everyday life. And it's about observing a corresponding change in the degree of a certain effect depending on the degree to which the cause is exercised. So, for example, the harder you work out, the stronger you become. And that's going to be a function of the degree to which you work out. So if you work out kind of in the middle spectrum, you're going to kind of not be too strong or not too weak, but the harder you work out, the stronger you become. The more you study, the better you'll perform, that kind of thing. So with concomitant variation, it's about learning what's going to increase the effect of what, depending on how much of the cause is going to be applied. So we've looked at Mill's basic methods for identifying the cause. They are the method of agreement, the method of difference, the method of concomitant variation, which I said was a fancy way of describing how the degree to which you increase the cause, you're going to increase the effect. The joint method, the method that uses the method of agreement and the method of difference, which is the method that is commonly used for drug testing, and it's more thorough than using either one of these alone. And these are methods that we normally use, I think, even in you didn't even have to come to a critical reasoning class to learn that this was a way to identify the cause. I think we instinctively understand that this would be a good way to identify the cause. However, it so happens that John Stuart Mill was very precise in characterizing what goes on in using these methods, and that's why these terms, method of agreement, method of difference, and so on, are named after the way that he called them. Now, I'm going to have to say that it's very difficult to actually come up with the relevant cause in a real-life case. When I come up with diagrams to illustrate the methods, it looks super easy to identify what the relevant differences are or what the relevant agreements are. In real life, things never look that neat and tidy, and it can take an awfully long time to identify what a relevant difference could be or what a relevant agreement could be. So I don't want to give any mistaken impressions that applying these methods would be an easy, direct thing to do. It can take years to actually figure out, for example, what it is that gets people sick, and what it is that could make people healthy. So because there are so many things, so many variables that are involved, and it's really hard to weed out the relevant variables from the irrelevant ones. So that's basically what this word of caution is for, that getting the data is not easy. It's going to take a lot of time, and scientific discovery is a slow process. And to continue along that vein, I want to cover some fallacies that can easily be committed without your intending to or without your knowing that you are committing these fallacies. And here is a list of some of the fallacies that you need to be aware of. So one of them is what's called misidentifying the relevant causal factors. So this is something that can happen when you're applying the method of agreement. So just because, for example, you identify a common factor, so going back to the original diagram before, where according to the diagram, it was the lettuce that caused the illness. Just because you identify the lettuce as the common factor for the illness doesn't mean that that's actually the cause. And the reason is because the lettuce could also have been in agreement with something else that was the real cause. And so, for example, maybe the lettuce was also put on the sandwiches with something like ketchup. I'm just saying for the sake of illustration. Maybe you didn't write down in your data notebook that ketchup was also a common thing that was consumed along with the lettuce. If you fail to identify ketchup as a common thing, you're not going to notice it as something to look for as the cause of the illness. And you might mistakenly identify the lettuce as what caused the illness, even though it wasn't the lettuce, it was the ketchup. The point is, when you collect data, you need to be as thorough as possible. So just because you have an agreement doesn't mean that it's the final word on what it is that caused the illness, because there could be lots of other agreements that you've overlooked. And part of scientific investigation is about being very thorough and looking for all the possible variables. And the same point applies to the method of difference and the method of concomitant variation. So just because you see some kind of correlation between two things, the correlation doesn't necessarily mean that you've identified the causal relation. And this is what mishandling multiple factors is about. In real life, you're going to have many, many, many variables that could be in effect when you try to diagnose why certain people got sick. And this is just basically a warning to say that there's always a possibility that you overlooked something. This goes along with the more general comment, namely, just because there is correlation, just because there's correlation between, say, X and Y, okay, that doesn't necessarily mean that there's causation of X causing Y. And this very, very important lesson to learn about how correlation doesn't always mean causation is a part of understanding that you could be committing a fallacy, namely the fallacy of being misled by a coincidence. So just a kind of silly example of how you can illustrate the difference between correlation and causation is by using the example of, say, suppose you're good about walking your dog in the morning, and every morning at 8 o'clock you walk your dog. Well, by 6 p.m., it gets dark outside. Now, there is a correlation between walking your dog in the morning and then subsequently it getting dark at 6 p.m. But despite the correlation, and despite how many times you witness the correlation, it doesn't mean that your walking the dog is causing it getting dark outside. So this is just an illustration of how a mere coincidence certainly doesn't mean that you have a causal relation. And again, in a similar vein as being misled by coincidence, there is the fallacy of confusing what causes what with mere temporal order. In other words, something in the past affecting something later. I don't know if you'll remember this. This is a good thing to review. In one of the fallacies that is covered in the YouTube video, I don't remember which part of the creationist fallacies, but one of the fallacies is committed by this person who starts to make associations. He starts to make associations with no longer requiring prayer in schools. And then, so in the past, there's a certain thing, namely no longer requiring prayer in schools. And then he points to a lot of things that happen that come after that, like marriages. I'm sorry, that pregnancies that happen outside of marriages, a higher rate of divorce, greater crime rates, and things of that sort. Even though the government saying that you don't need to require prayer in schools might have happened, it might have happened before these things happened that the person is talking about, doesn't mean that not having people pray is causing these things that are considered to be socially problematic. And finally, making sure that you don't confuse the cause with the effect. So, for example, the example that's being used here, there's been some studies that show that people with pets tend to be happier. Now, one might think that getting pets causes happiness. That's one hypothesis, and it's a perfectly reasonable one. However, that's not the only hypothesis. The other hypothesis is that people who are already happier to begin with are ones who get pets, which explains why there's a correlation between pets and being happier. So you have to always constantly be on the lookout for whether what you identify as the cause is really the cause. And all of this is basically to say that identifying the cause and identifying the effect really require accumulating a lot of data, sorting through the data, and looking at alternative ways of explaining what could be causing what. It's very easy to be misled by coincidence. It's very easy to be led by coincidence or by temporal order, or confusing the cause and the effect. It's very easy to fall into these fallacies. Nobody commits a fallacy because they want to, and nobody thinks that they're being careless. However, to be a good critical reasoner, you have to always be on the lookout for whether or not you might be falling prey to one of these fallacies. And being open-minded about the fact that you might be wrong is one of the important attitudes that you try to cultivate as a good critical reasoner.